Okay, and in this video I will prove the change of base formula for logs. So what is the change of base formula? Well, it basically says that if you have a log of some base a to the x, you can rewrite it as log of some base b of x over log of that same base b of a. And let me give you an example. Why is this useful? Well, suppose you were looking at something like this. Log base 3 of 10. Okay, if we wanted to find out what that was, that would be very difficult to find out what that was. Normally what we would do is say, okay, set it equal to y, translate it, and you get 3 to the y equals 10. Well, you can't make 10 power of 3. You can't rewrite 10 easily as a power of 3. So this way sucks. Now, you might want to plug it into your calculator though. So this is where the change of base formula comes in. So the change of base formula, if you want to evaluate this logarithm on your calculator, normally you can only do log base 10 of whatever x, or log base e of whatever, and we just write that as ln of x. Okay, so these are the two logs you can take on your calculator. So if we were going to evaluate this log right here, log base 3 of 10, what we would do is, here a is 3 and x is 10. What we would do is write it as log base 10 of 10 over log base 10 of 3. Well, log base 10 of 10 is, well, you can put in your calculator, but it's going to be 1. And that just happened here. I just want to demonstrate that same thing. So this right here would be just log base 10 of 3, but you could put this in your calculator. You could put this in your calculator as 1 over log 3. And that's where change of base is important. It makes it so that you can evaluate with your calculator logarithms you wouldn't normally be allowed to evaluate with your calculator, because, like I said, the only bases that the calculator uses is 10 and e, or the ln. Okay, so that's why it's important, but why is it so? And to show you why that is, I'm going to do the following. I'm going to start with this side right here, this left-hand side, and I'm going to show you a proof. I'm going to say let y equal log base a of x, and what we eventually want to show is that that is equal to this right here. Okay, well, if we take this and we translate it into its corresponding exponential form, we get a to the y equals x. Now, by our one-to-one property of logs, if this is equal to this, then the log base b of this is equal to the log base b of this. And I just introduced b because you can take it, I could have taken any kind of log. That's why I have a b in there. I can log of base 3, log of base 10, whatever. Right? Okay, so now that we have that, what we can say is let's use our power rule, and remember, this is the power property. The power prop says that if we have a log base b of x to the p, we can rewrite it as p times log base b of x. So basically that exponent comes down. That's what we're going to do here. We're going to apply the power property, and we're just going to put this guy over here. And so the next line will be y times log base b of a equals log base b of x. And then if we divide both sides by log base b of a, what we get is exactly what we wanted. Y equals log base b of x over log base b of a. Now, what's y? Well, y is log base a of x. Remember our first step there. Let y equal log base a of x. So instead of y, I'm just going to put log base a of x. And there you have it. The proof is complete. Thank you for watching, and visit onlinemathacademy.com for any math tutoring needs, exam prep. Onlinemathacademy.com offers a fantastic, convenient, and practical way to not only get your lessons, but have live videos of your lessons and rewatch them. It also affords you the convenience of not being in the situation where you need to travel or have somebody to come over to tutor you. It's all done online in an online collaborative classroom where we write and talk, and we can even see each other if you want to see my beautiful face. But anyway, it's there if you need it. Come check me out on Facebook and on my website. Catch you later. Hope you learned something.